So sharding is a technique that is a specific version of horizontal partitioning, right? That is used oftentimes, especially in MongoDB. You use a lot. You hear a lot about sharding. That you want to spread the load across multiple instances of say MongoDB, and you want to segment in such a way again where you have certain records in one table and certain records in another table, but also hosted independently in different instances. So it's kind of a combination of horizontal partitioning and splitting it up into multiple nodes. Now, some of the disadvantages of horizontal sharding is that obviously when you're going to write all the queries, the integration between these systems now starts to become much more complex, right? The logic of making it look as if it were one single database is much more complex. If you have transactions that are failing, recuperating from a transaction is much more complicated, right? Because it failed on a particular table and it didn't fail on another table, but they're actually part of they're part of the same table, but they have been split for performance reasons, right? So if you're going to do a rollback on a record on one table, you're going to have to do the rollback also on the other table, even though they have been split into separate tables. So the indexing becomes much more complicated, and knowing that the index is going to reference one of the records in one of the tables that has been partitioned vertically, but it's not referencing the other. But logically, they are the same table, right? So it becomes much more complicated. Right. So when we talk about partitioning, horizontal partitioning, we mean that it's in the same instance, right? In the same database instance running in the same server, whereas sharding can be across multiple instances that are running. You're doing the horizontal partitioning, but across multiple instances that are running in tandem. One might be running, on the East Coast, one might be running on the West Coast, but they're part of the same database. And now obviously, if the queries are to your particular shard, then certainly you can see bumps in your performance. But if your query goes across shards, that definitely is going to be a much higher performance hit, right? Because the database the data is not local to you, and you need to go across multiple instances. Also, that typically there's quite a bit of redundancy across multiple shards, where not only are you going to have the shards that are only for the East Coast or shards that are only for the West Coast, there are also tables that were not sharded, right? They were not partitioned, but are needed for both instances. So there might be smaller tables that contain smaller pieces of information that weren't necessary to partition in the first place. But the whole logical application is assuming that not only does it have its own particular copy of the shard, but it also has copies of the smaller tables as well. So usually there's some redundancy where you not only do you have the copies that are specific to your geographical region, but also smaller copies of smaller data tables that were not partitioned but need to be copied and be redundant across multiple instances because the application needs all these tables, right? So that adds an additional inconvenience, an additional complexity that you have to make sure that those smaller tables are continuously synced, right? If you do an update on one of them, you need to make sure that that update goes across all your different instances, right? So certainly much more complicated. So much harder to back up, right? Much harder to do operations on them. The DBAs, for maintaining this is much more complicated. SQL has to be rewritten in terms of being dependent on that. Now these tables have been partitioned and create all the extra views to make it look like if it were the same table.